let's jump right in. If you're designing or commissioning electrical systems for an offshore drilling rig, well, you already know the harsh reality, right? Space is incredibly tight. The environment is just brutal, and your margin for error? Yeah, practically non-existent. Every single piece of equipment has to pull its weight without adding any unnecessary complications. So today, we're looking at a piece of hardware that handles these exact constraints brilliantly, the RESIBLOC dry-type transformer. We're going to see exactly why this is considered the ultimate engineering solution for tight offshore electrical rooms and why understanding its mechanics is an absolute must for any rigorous commissioning process.
Now take a look at this. What you don't see in this design is honestly just as important as what you do see. Notice how this transformer just sits entirely in the open air? There's no heavy protective metal tank built around it, and there's definitely no complex fire suppression system enveloping the unit. It's completely exposed. And no, that isn't some cheap cost-cutting measure. That simplicity? That's entirely by design.
Literally, no oil, no tank, just cast resin. Think about it. On an offshore rig, every square inch of deck space is heavily contested real estate. Hazards are quite literally everywhere. So introducing thousands of gallons of insulating oil into an enclosed space, that brings massive fire risks and huge weight penalties. By eliminating those insulating oils and those bulky containment tanks altogether, this exact level of mechanical simplicity becomes the core selling point. You get less infrastructure, way less risk, and significantly less maintenance for the crew. Okay, let's move to the physical construction. You'll hear the term resin cast winding. But what does that actually mean? Well, it means the copper windings are tightly wrapped in resin-impregnated glass fiber bands, and then that whole structure is cured into a single, solid mechanical block. We're talking about an 80% glass content construction here. Curing it this way physically locks the coil geometry into place forever. It becomes this rigid, dense, immovable object.
And that 80% glass content translates directly into something absolutely crucial: exceptional short-circuit withstand capability. See, if a massive fault current surges through the winding, electromagnetic forces violently try to tear those coils apart. An unreinforced, loosely wound coil? It would instantly deform and fail. But because the resin has already locked the RESIBLOC's geometry into a solid mass, the winding physically can't deform. It holds its shape perfectly and just survives the surge.
So, quick check here. Why is zero silicon called out as a specific selling point for offshore use rather than just being some clever marketing language? Take a second to really think about it. If you're out there commissioning a rig, why on earth do you care if there's silicon in the construction of your transformer? Well, this isn't a buzzword. It actually points directly to a silent, real-world failure mode that has plagued operators for years. The culprit is silicon migration. It's a highly documented offshore contact fouling risk. In those tightly packed electrical rooms, the atmosphere gets hot, right? Over time, silicon-based materials can actually off-gas, migrate right through the air, and settle on sensitive electrical contacts and really expensive switchgear nearby. It literally insulates those contacts and ruins them. It's basically a silent, invisible killer of electrical reliability. But by using absolute zero silicon in its construction, the RESIBLOC prevents that compound migration entirely. For a commissioning engineer, specifying this zero silicon design completely eliminates a known offshore reliability problem right at the source. You don't have to plan tricky maintenance around it, and you don't need expensive mitigations down the line. Why? Because you've engineered the risk entirely out of the room from day one. It's a huge win. Now look at this number, 40 MVA, 40 megavolt amperes. That is a massive amount of power capacity. But you know what's truly incredible? A RESIBLOC transformer handles this rating entirely through natural convection. This isn't just some tiny auxiliary unit. We're talking highly meaningful capacity suitable for heavy-duty rig switchboard step-down operations. And it does all of that without needing complex external cooling systems bolted onto it. Let's break down exactly why that natural cooling is such a game-changer. Competitor units operating at these high capacities almost always rely on forced air cooling. And that means dedicated fan power, rotating mechanical components, and heavy maintenance in spaces where you can barely even fit a wrench. But the RESIBLOC, it cools itself naturally. Dropping the fans means one less rotating, maintenance-hungry component in your transformer room. Simply put, less to fail and less to maintain in a space that's already incredibly tight. Okay, let's pull all this together. Before this explainer, you might have just thought of a dry-type transformer as kind of a generic category of equipment, but now you know the exact traits of a RESIBLOC specifically. You've got resin-cast windings for absolute mechanical short-circuit strength. You've got zero silicone construction to avoid contact contamination entirely, natural convection cooling with zero fans required, and, to top it all off, high-capacity handling up to 40 MVA without breaking a sweat.
But as brilliant as the RESIBLOC is, it isn't the only option out there. Next time, we're going to dive into the other major transformer family, liquid-immersed transformers. We'll explore multi-winding configurations, insulation fluids, and why classification society approvals dictate your entire design. Until then, ask yourself this: is the brilliant simplicity of a dry-type system always enough for your grid? Or are there offshore environments where complex harmonic cancellation becomes the only thing keeping your rig alive? We'll find out next.